Hello, Geometry Crew. Today we're on day 7 of our SAT unit, and we're going to talk about absolute value equations. This will be very familiar from what you saw last year in Algebra 1. So let's get started here. We're only going to go over a few examples. Remember that an absolute value is the distance a number is from 0 on the number line. Because it represents a distance, an absolute value is always positive. Right, so two examples we can see here is the absolute value of 4 and the absolute value of negative 4. So the reason why the absolute value of 4 and negative 4 is both 4 because 4 and negative 4 is 4 units away from 0 on the number line. So it's just representing the number of spaces it's away from 0 on the number line. That's basically what an absolute value is. Let me bring up my tools really quick. There we go. So to solve an absolute value equation, we're going to isolate the absolute value first if it's not already isolated, and then we're going to generate two equations. Okay, so an absolute value equation is an equation that contains an absolute value expression. Okay, here are the steps to solve. All right, once we generate our two equations, we're going to solve both and check our solutions. Okay, so in example 1, part A, it says the absolute value of the quantity x minus 4 equals 6. Right, so remember what an absolute value means. It just means that the distance from 0 on the number line is 6. So whatever this is, it's 6 units away from 0 on the number line. So if we're thinking about where this quantity could be, it could be at 6, and it could be at negative 6. So this is step 2 when it says generate two equations. What's inside the absolute value expression, okay, is 6 units away from 0. So it can be at 6 or negative 6. Then we're going to solve for x. So we're going to add 4, and we get 10. And then we're going to add 4 over here as well, and we get negative 2. All right, so if we're graphing the solutions, I'm just going to go up by 2's here. All right, let's say that this is negative 4, so that's negative 2, 0, 2, 4, 6, 8, 10, and then 12. All right, we're just going to put a closed-in circle where our solutions are. Okay, so our two solutions are 10 and negative 2, and that's where they are on the number line. All right, if we take a look at example B, all right, we have our absolute value isolated. All right, so that means we can move on to the next step. Well, notice this says the absolute value of this expression is negative 5. So that's saying that this thing, whatever it is negative 5 units away from 0 on the number line. If we're thinking about 0 on the number line, all right, negative 5 units away from 0, that's neither going to be 5 nor negative 5. Okay, negative 5 is still 5 units away from 0 on the number line. Okay, so in terms of our solution, there is none. No solution here, because nothing is negative 5 units away from 0 on the number line. All right, let's move on. In part C, all right, first thing that we have to do is isolate the absolute value. So first we'd add 10 to both sides. And we get the absolute value of 3x plus 9 equals 6. Now this absolute value, whatever it is, this quantity is 6 units away from 0 on the number line. So like before, it could either be at 6 or it could be at negative 6. And that would still be 6 units away from 0 on the number line. And now we're just going to take those steps to solve from here. So subtract 9, and we get negative 3. Divide by 3, and we get negative 1. It's going to be the same steps here, so subtract 9 once again. And this time we get negative 15. Divide by 3, and we get negative 5. All right, those are the two positions that we're talking about on the number line. Those are the two solutions. So if we plug it back in, it makes this equation true. All right, let's just do that in this first example. If we plug negative 1 in, we have to verify that the left side of this equation equals -4. So first thing that we would do is multiply 3 times -1, which is -3. -3 plus 9 is 6. The absolute value of 6 is just 6. And 6 minus 10 is -4. So this one works. All right, now let's do the same thing for -5. So if we plug -5 in, three times -5 is -15. -15 plus 6 is -6. Sorry, -15 plus 9 is -6. The absolute value of -6 is 6, and then 6 minus 10 we have again, which is -4. So that one works as well. All right, so both of those are solutions because they make the original equation true. All right, let's take a look at part D. In this one, we have multiple things happening outside the absolute value. We've got to get rid of those things before generating our two equations. All right, so the first thing that we could do is add 3 to both sides. If we're ever wondering what we do first, which one of these things we get rid of first, just imagine that this absolute value is just x. Okay, and we'd do the same thing that we would do with this equation. We'd add 3 first, then divide by -2 to get x by itself. So it's the same steps to solve. So we get -2 times the absolute value of the quantity 5x minus 1 equals -8. Now we're going to divide by -2 on both sides. And that's going to isolate our absolute value. So we have the absolute value of the quantity 5x minus 1 equals 4. All right, so that means this thing, whatever it is, it could be at 4 and it could be at -4. So we're going to generate our two equations. And then solve from there. So we would add 1. We get 5x equals 5. Divide by 5. We get x equals 1. Add 1 in the second example. Right, and we get 5x equals -3, divide by 5, and we get x equals -3/5. So there's our two solutions. All right, let me clear the board here. Now let's say we have absolute values on both sides of the equation. Let me extend this page here. In example 2, I'm just going to move this stuff down here so to give us some extra space. In example 2, notice we have absolute values on both sides. So both of these things could either be at the positive position on the number line or at the negative position on the number line. So really we don't know whether this is negative or positive. But if we run through the possible things that could happen, okay, this quantity could be negative, and that quantity could be negative. That quantity could be at the positive position. Same thing with this one. We could have the positive position, and then the negative position, and then the negative position, and the positive position. So if they were both negative, okay, if they were both negative at the negative position on the number line, the first step would be to just divide by -1. And in that sense, this case is the same as this case. We'd get rid of the negatives, okay, and we'd be at that positive position again, essentially. And the same is true for this example. Right, if this one was positive and that one is negative, okay, or if that one's a negative and this one is positive, if the first quantity was negative and we were isolating that quantity, we would divide by -1, and then it would just change the signs. So once again, these two cases are essentially the same as those two cases. So we don't have to run through the 4 different scenarios that are possible. All we have to do is just run through one of these and one of these. Okay, so what we're going to do is we're going to set this second quantity equal to the same thing that it shows inside the absolute values, and then we're going to say, oh wait, maybe it could be at the negative position, so we're going to make it negative. All right, so we're going to set x plus 8 equal to 2x plus 1. That's one of our equations. And the second equation is going to be setting that x plus 8 equal to the negative position. So when we do this, we're going to make that whole quantity negative. So you're going to see me putting parentheses around it, because that whole thing could be at the negative position. Now we're going to just solve both of these equations. So if we subtract x on both sides in this first example, we'd get x alone on the right side, and then we'd want to get our constants on the other side, so we could subtract 1. And we get x equals 7 as one of our solutions. In the second example, we're going to distribute the negative first. So we'd get negative 2x minus 2. And then we're going to get our variables on one side, our constants on the other. So I'm going to add 2x to both sides. And we get 3x. Subtract 8 to get the constants over to the other side. We get negative 10. And when we divide by 3, we get negative 10 thirds. So our two solutions is positive 7 and negative 10 thirds. Just remember that when we're doing these problems, all we have to do is set the quantity on the right equal to the positive position and then the negative position. So if we take a look at example B, we don't really have to do anything on this left side. Now this is saying 3 times the quantity. Okay, so if we were to rewrite this, that would be 3 times the quantity x plus 4. Or sorry, x minus 4. All right, and then this quantity on the right side, we're going to make it positive. So we're not going to change it. And then for our other equation, just take this. I can't move it? Okay. I'm just going to write it on the left side here. Now we're going to take that same quantity on the left side and set it equal to the times the quantity 2x plus 5. And now let's solve both of these. All right, so on this first one that we set up, the positive version, we're going to distribute. Then we're going to get all of our x's over to one side, so I'm going to subtract 2x. That'll leave me with x on the left side. Add 12, and that'll give us 17 on the right side. In the next part, we're going to distribute that 3 again. We get the same thing. Now we need to distribute the negative. So we're going to have negative 2x minus 5. And once again, we're going to get all the constants on one side and all the variables on the other. So I'm going to add 2x. We get 5x on one side. Add 12. We get 7 on the other. And when we divide by 5, we get 7/5. Awesome. All right, let's move on to the third example here. I'm going to move this up to give us plenty of space here. And in example 3, you're going to notice we have 2 expressions, one on the left, one on the right, of course. The one on the right has a variable, but still that doesn't change the steps that we take to solve this. All right, we have the absolute value isolated, so we're going to set 2x plus 12 equal to 4x, and 2x plus 12 equal to negative 4x, and just solve both of those equations. So in this one, I'm going to subtract 2x on both sides. So we get 12 equals 2x, and I wrote 14, so that's interesting. There we go, 12 equals 2x. And then divide by 2 on both sides, and we'll get x equals 6. On the right equation, I'm going to add this 4x over, and I'm going to subtract 12. Okay, so we get 6x equals negative 12, and then divide by 6. We get x equals negative 2. All right, it's important to check our solutions, especially in this case where we have an expression on the right with a variable, because when we plug this back in, we'll see that maybe one of them works and maybe one doesn't. So if we plug in 6, right, we're going to get the absolute value of 2 times 6 plus 12. I'm just going to do that whole thing. 2 times 6 is 12, 12 plus 12 is 24, and the absolute value would be 24. And then on the right here, that's 4 times 6, which is 24. So we can see that works. But in this next example, when we plug in -2, notice we don't have to go very far in this example to figure out that this isn't going to work. If we just evaluate the right side, 4 times -2 is -8. And what this is saying is, whatever this absolute value is, its distance is -8 units away from 0 on the number line, which we know can't be true. Both 8 and -8 are both 8 units away from 0. So that can't be true, so that means -2 is not a solution. All right, those are the tricky ones. All right, let's move on to the last example. This one's a really basic example that you've probably seen before. In example 4, it says, write an absolute value equation to demonstrate this scenario. Right? In a cheerleading competition, the minimum length of a routine is 4 minutes. The maximum length of a routine is 5 minutes. Write an absolute value equation that represents the minimum and maximum lengths. Okay, so if we're struggling, it's always useful to have a diagram. So we could always, we could have a diagram that models this scenario. Okay, so if I draw just like a little basic number line here, all right, the minimum length for the routine is 4 minutes. The maximum length for the routine is 5 minutes. All right, so these are basically our solutions, and what we've got to determine is, what is that middle point there? What is that distance that is equal? Okay, so it doesn't take much to do this, but to figure out, what's in the middle, we just take the average, 4 plus 5 divided by 2, right, which hopefully we know that's just 4.5. So the minimum and maximum routines are just half a minute away from each other. All right, so this represents basically the distance. All right, so that's what our absolute value equation equals. It equals a distance. So this, whatever the absolute value is going to equal 0.5. And actually, I put an equation there, and I don't want that, because it doesn't have to be 4 minutes or 5 minutes. It's just got to be within this range. So it's got to be less than or equal to 0.5 units away from 4.5 from 4.5 in terms of the routine. So the important things is that number in the middle and then that distance. That number in the middle is the distance that we have to look at. All right, 4 minutes is a half a minute away from 4.5. 5 minutes is a half a minute away from 4.5 also. So whatever our routine is, and we could just call it x, its difference from 4.5, that middle point, has to be less than or equal to 0.5. All right, so the absolute value of this expression has to be less than or equal to 0.5. All right, so important things is just the middle value and then that distance, and we could set up an absolute value equation. All right, folks, that's it. If you have any questions on the notes, on the homework, or anything, make sure to ask me. Thank you, and have a good day.